In this module, we're going to talk about shared storage. When I was a database administrator, I was really frustrated with the SAN. I was so bummed out. I kept getting these 15-second error warnings, and I kept going, man, our SAN sucks. I'm tired of all these SAN problems. And I just was so frustrated. We spent millions of dollars on our storage, and it would never perform the way we wanted it to. And I also managed some of the VMware infrastructure, and I'm like, man, the VMware infrastructure is sucking too, all because of the SAN. One day, my SAN administrator gets a better job and leaves. He didn't report to me. He was in the same team as me, but he didn't report to me. I went straight into my boss's office, and I'm like, here's the deal. You give me all of his job responsibilities. I'll do all his work. You don't have to pay me a single dollar extra. I'll just add additional duties. I'll work weekends. But I was convinced that it was a SAN problem, that these were all widespread SAN problems, and that was the reason why my stuff wasn't going fast enough. I just took his training budget, his passwords, and figured I'd rewire everything so that it worked better. And what I learned very quickly along the way was that it wasn't a SAN problem, that a lot of what I was doing was my problem as a database administrator. It opened up huge eyes for me, and I just went, oh, now I get it. So what I'm going to try and do in this module is I'm going to try to teach you the bare minimum of what you need to know as a database administrator about how shared storage works, so that you can use the same language with your storage administrators, and you can understand what changes you need to make to your SQL Server in order to get the most out of your storage. This isn't the performance tuning class, but we are going to touch a little bit on performance just because that's really important for shared storage. We're going to start with a physical SQL Server. This physical SQL Server is in what I call my IKEA data center over there in the corner. So that unit right over there is a big roll-top IKEA cabinet that houses things like my lab servers, which I use less and less these days because I'm so much more in Google Cloud, Amazon Cloud. So I have a physical SQL Server in there called an HP ProLiant microserver. And say that I want to take, it's an actual SQL server, say that I want to take the data and log files out and I want to put them on shared storage. Well, I want to put them out on the SAN. Now, the first thing that I'm going to do is I'm going to go open the front of that. And when you open the front of it, there's its data and log files. They're all sitting on 4 hot swap removable hard drives. So I can actually pull those hard drives out. This is where my data and log files live. This is the first part of shared storage, your hard drives or solid state drives. The next part of shared storage would be to pull out of that SQL Server its RAID card or RAID controller. RAID stands for Redundant Array of Inexpensive Drives. Some people will say independent drives. So that I can use a stack of several hard drives and spread my data across them. If one of the drives fails, the RAID card is the piece that understands that the drive failed and starts moving data over onto other drives. It keeps copies of the data on multiple drives, manages retrieving the data as quickly as possible, manages writing data to the right places at the right times. It also has caching on board, has RAM, so that as soon as you write something, it's considered committed as soon as it hits that cache. These are complex computers on a chip. They're really powerful stuff. That's also going to move out over to the shared storage because the shared storage is going to manage where all of my data lives. I also have one other piece, which is the cable that connects my server to its shared storage. I have to have some kind of cabling infrastructure that gets in between these devices, and it needs to be as reliable as possible because obviously I don't want to lose connection to my storage. This is what shared storage is. I have the server that has my HP ProLiant microserver, that one up at the top. Then I have what's really the SAN. When you and I use the term SAN, SAN stands for Storage Area Network. It refers to the cables and the switches in between the server and the SAN. We like to say things like, the SAN is slow, and our SAN administrator gets all angry. He's like, that's not really the SAN. Come on, that's not. It would be like as if your developers came up to you and said, the app is slow, when they really meant the database is slow, and we would kind of laugh and agree with them, like, yeah, you're right, the app is slow. We wouldn't take each other seriously because we're not using the same vocabulary. Then finally, at the other end of the cables, you have your shared storage gear. Now, I use the term shared storage gear. It's very different based on your vendor. So EMC, NetApp, Hitachi, IBM, Dell, Compellent, Equalogic, these are all brands that use slightly different terminology. They'll say things like filers or controllers or heads. So if you just say the shared storage gear, it tends to be easier to understand with your SAN admins. This piece in the middle turns out to be really important. It's all about storage pathing. How do we carve a path from our SQL Server over to the shared storage gear on the other side? Your server, in my case, my HP ProLiant microserver, has what's called a host bus adapter in it, HBA. Host bus adapter is nothing more than a fancy pants name for a network card. Maybe it's fiber optic, or maybe it's 10 gig iSCSI, but it's just a cable, a network card plugging in a cable that then plugs into a switch, which is a lot like a plain old network switch, like maybe you've got Cisco switches or Dell switches inside your data center. But these are generally dedicated just to storage. Then I have another cable plugged into my Equalogic, Hitachi, NetApp, whatever. Now, this will work, but as you can see through here, there's a whole lot of single points of failure, or as I like to call them, single points of success. With single points of failure, that's not very reliable. SAN guys, so storage administrators, aim for what we call dial tone reliability. They want the SAN to be as reliable as Grandpa's phone that used to hang on the wall. Grandpa could pick up the phone even when there was a power outage, and he would always get a dial tone so that he could call the power company or whatever. So in order to achieve that, what SAN administrators do is they will plug 2 cables into every SQL server via 2 different host bus adapters, so that if either one fails, we still have our own totally separate path to get to the shared storage. This is pathing, figuring out which path I'm going to take to get to my SAN. This is really much more common to see in data centers, and I'm going to see 2 different paths, or often I'm going to see 8 or 12 or 16 different paths, because my shared storage gear is probably going to be plugged in with a whole lot of cables, because after all, there's just not one SQL server on the other side. There's several SQL servers and VMware servers, file and print servers that are all connected to my SAN. All of them need to get a whole lot of throughput, so each one of these guys may have a dozen or more cables plugged into it, even though each individual SQL server usually only has 2. You might think that just by having 2 cables plugged in, that it's instantly going to be twice as fast. That's not how it works. Active-active multipathing is a lot like active-active clustering. Grandpa used to call his clusters active-active when he had 2 nodes in them and they were both active at the same time. But they weren't active for the same database at the same time. One of his instances may have been for accounting, the other instance may have been for SharePoint, for example. Having 2 active instances didn't mean you were twice as fast, because one database was only running on one instance at any given time. That's very similar to how this active-active multipathing works. You may have 2 cables plugged into the SAN. That doesn't mean they're both used for the same thing at the same time. Very typically, when we're looking at multiple cables plugged in, we'll see that all data coming from the shared storage goes back through just one path. I do have 2 available, but they're more for redundancy than they are for reading data. Usually, when I'm reading data, I'm bottlenecked by just one cable. Usually shared storage will accept writes through multiple cables, but that's not what SQL Server spends most of its time doing. Most of its time it's spent reading, because we have a very limited amount of RAM on SQL Server, and we need to access a whole lot of data that we can't cache. The data's just too large for us to fit in cache. Shared storage is a whole lot like libraries. If you go to the congressional library or your local library, you may have a staggeringly huge amount of books. Fantastic amount of information that's contained within the library. Latency is how quickly you can run into the library, find exactly one book, and check it out. How quickly can you run all the way into there and grab just the one book that you need, and that's it? That's latency, how quickly you respond per request. Throughput is a different measurement. What happens when a whole bunch of people all need to check out a whole bunch of books at once? That's a very different number, and as you can imagine, the tests for that look very different. If I have a very small checkout line at the library, sure, it can respond quickly to latency for one request at a time, but as soon as you put it under load, suddenly you start to run into problems. The network is your checkout line at the library, the pipe between your SQL Server and the shared storage. This is where we run into problems with throughput. I used to think before I was a SAN administrator, wow, these cables are fiber optic. They must be fast. Nothing's faster than light, right? Well, it comes down to what kind of signaling you do with light. For example, if I was flashing Morse code at you here, our communications would be extremely slow. Fiber channel, fiber optic, and even 10 gig iSCSI is not quite as fast as it looks. When I throw these throughput numbers up here, that doesn't really mean anything to database administrators. We don't know what 4 gig fiber channel means. So Kendra drew this really slick little poster to help explain how fast bandwidth really is. If you have, say for example, 8 gig fiber channel, that's 850 megabytes per second, which still may not mean a lot to you. But if I put it in terms of how long will it take to transfer 1 gig of data, 1.2 seconds doesn't sound like a lot of time until you think about scanning a 10 gig table or a 50 gig table. If it's not in cache, up in memory, in your SQL Server, how long will it take to transfer that data across the network? SAN administrators are like, well, what the hell are you reading a 10 gig table over and over for? Well, because I don't have enough memory in SQL Server to cache it. I have, say, a terabyte worth of data and only 64 gigs of RAM. If the data I want isn't in RAM, I'm going to have to copy it from disk up into RAM every time my query runs. So we need to test our storage throughput and see how fast it is. Most of the time when we do storage testing, we very quickly bang up against the bottleneck of however our SQL Server is connected to storage, and I'm usually banging up the limits of just one cable. It's really easy to test storage throughput. There's a totally free tool that'll do it. It's called Crystal Disk Mark. If you Google for Crystal Disk Mark, it's going to take you to the download page. The download page looks a little different than what I've got on the screen here, but I keep this screenshot for a reason. Today, the Crystal Disk Mark, and you got to be careful because there's also a Crystal Disk Info. You want Crystal Disk Mark. It has several different versions. You want the portable edition because it does not have ads. They've learned over time that people won't click on the one with ads who wants ads on their server, so they've taken off the words with ads or without ads. That's why I'm telling you that you want the portable version. It does not have ads. There's also, if you want the Shizuku edition, it has anime characters on it. So if you're into like manga, then, that's kind of cool too, I guess. But I say I guess, I like manga, but the thing is that's going to end up in your screenshot, so it's going to look kind of goofy. So what I'm going to do is I'm going to go grab the portable edition without ads. And I'm actually going to run this on my VM here and explain how this works. So let's go pop out and go look into my SQL Server. So I have SQL Server 2016A. This is the same version or the same machine I ran the demos on day one, but I've already downloaded Crystal Disk Mark. I put it in a folder in my temp file or my temp folder where I keep everything valuable. There's 2 versions of Crystal Disk Mark. I'm going to work on the x64 version because I'm running a 64-bit operating system. I'm just going to double click on that. You do have to run it on the SQL Server that you want to test. So start this on a dev box. You're going to run it in a development environment just to get a rough idea for how this thing works and how your shared storage is. There's 3 drop downs across the top. I'm going to minimize my background there so you can see better. So there's 3 drop downs across the top. The top one, the first one is, how many tests do you want to run? I'm just going to run 1 test because I'm not really burning this server in. Excuse me. But if you're building a brand new server from scratch and you want to get really repeatable numbers, you would run 9 tests in a row. Next drop down is, how big do I want my test file to be? When I'm really testing the bejesus out of the sand, I'm going to crank it up to 32 gigs because my databases are fairly large, usually larger than that. But when I'm just trying to do a quick test to see how bad my server sucks, I'm fine with doing just a 1 gig test file. The problem with doing a big, huge file like 32 gigs is that Crystal Disk Mark has to go create that file. If you've got crappy storage, it's going to take a long time to write out a 32 gig file. So let's say 1 gig here. And then I'm going to pick where I want to test. I'm going to test where my data files live, where my log files live, where tempdb is. And I'm usually even going to test the C drive on the SQL Server. Because in physical boxes, sometimes the C drive on the SQL Server is actually faster than where my data and my log files live. In this example, my log files or my data and log files live on the M drive, so I'm going to go test the M drive. And then I'm going to click the All button. Now, while this thing runs, the title bar up at the top explains the step it's working on right now, like preparing or doing the sequential read tests. And the legends disappear whenever I start running this test. I'm going to explain what those mean. The top one, and the legends will reappear when the test finishes. The top set of tests is sequential operations, big, long, sustained reads or big, long, sustained writes, all in a row. This is generally the best case scenario for your SQL Server and its storage. So here you can see I'm getting about 833 megabytes per second worth of reads. In a second, you're also going to see how fast my sequential writes go. Sequential reads are like scanning a table that's been perfectly defragmented. Except it's like only one person scanning that table. That's fairly unusual. In an active SQL Server, especially a transactional SQL Server, people are jumping around reading all over the place, and they're not usually scanning large objects. So that top number is not perfectly accurate for a lot of SQL servers, especially transactional stuff. It is relevant for data warehouses, where you have a big monster table and people just scan that table all day long. The sequential writes, this is not like what we do very much in SQL Server. The only thing it's really like is taking a backup, like where we write our backups to. But even bulk loading data in isn't usually sequential writes, because you usually end up writing to several different tables all at once. The second row down is random activity. A lot of different reads or writes happening all over at the same time. This is very similar to transactional SQL servers and to tempdb, because typically we've got, say, 8 different tempdb data files or more. We'll talk about that later. So you'll notice there's a huge difference here. Sequentials on this particular piece of storage are roughly 20x faster than randoms. This leads to an interesting discussion. In the old days, when Grandpa was managing dedicated SQL servers, Grandpa would say, you should put your log files on a separate drive, because log file access is sequential, We start at the beginning of the log file and we write to the end of the log file. Then we come back around to the beginning and we write through the log file. Grandpa says, if you could separate your sequential activity from your random activity, it'll be like 20 times faster. So you should make sure you get fast log writes. Well, Grandpa was right when we only had one database. Grandpa, back in the good old days, had dedicated SQL servers. Back before SQL Server was very popular, only 1 or 2 databases per server. Today, that's not how most of your SQL servers look. Some of you may have a data warehouse that has a big database and has its own log, and that's it. But most of us have, say, 20, 50, 100 or more databases per SQL server, and they're all active at the same time. It's not like we go, hold up, everybody, I'm going to do some writes on database A. We're writing all over the place to all of the transaction log files randomly. This is why you'll see in most vendor best practices these days, they don't say to separate the data and log files because all access is effectively random anyway, especially when you start to get into shared storage. So having said that, you can see roughly how fast my storage is. When I'm doing sequential operations, I'm getting like 833 megabytes per second for reads. When I'm doing random operations, I'm getting about 44 megabytes per second of reads. What I'm going to do is I'm going to say SQL prod 1. See, this little box down here is an edit box where you can just type directly into. SQL prod 1, data and log files, 2017-04-13. So that this way I can take a screenshot of that and I can save it for later. Or I can email it to my SAN administrator and just say, hey, is this the throughput that you were expecting? What I'm going to include is screenshots of the data file, the log file, or the drives, the data drive, the log drive, the tempdb drive, the C drive, and I'm also going to include my laptop just as a rough, guess so people can see how fast that thing is. What I'll usually find is that a modern laptop with solid state smokes wherever my data and log files are. So that's a huge problem for me. So I'll just ask the SAN administrator, is this what we're expecting to see out of our shared storage? Usually, you're going to end up hitting the cabling as a problem wherever your VM is hosted. The cables, or your VM, I'm looking at my VM and thinking through my infrastructure here. Wherever your SQL Server is, the cabling between the SQL Server and its data and log files, this is the bottleneck that you typically hit when we're talking about big sequential operations. And it doesn't matter whether you put 100 drives on the other side, whether you do RAID 5, RAID 6, RAID 10, you're going to bang up against the bottlenecks of the cables in between those. Now, when you're doing random operations, that's a different story. But up here with sequentials, I can see what my limits are, and then I can ask my SAN administrator, is this what we expect to see? Sometimes my SAN administrator will say, well, I don't really care about throughput. I care about IOPS. How many IOPS can you do? Well, all right, fine. If you want to see that, I don't put any faith into that, but if they want, and there are times when IOPS make sense, but not for SQL Server general throughput testing. If he wants to see that, you click File, Copy, then you start up Notepad, click Edit and Paste, and look at what you get here. Let me arrange it so you can see it a little better. So now you have that same information all in a text format, including, this is where Brent just typed in his little header line there, or his footer line. But you also get IOPS. For the random operations, you can see how many input and output operations they get per second. If SAN guys want to deal with that, that's totally fine as well. My goal here is to give them just an I/O report to say, how fast is my storage today, and what are good and bad numbers? The first thing that people usually notice, if they have a laptop with solid state, especially a recent laptop with PCI Express solid state, that their laptop will smoke the SAN. And when the SAN administrator says, can you tell me what you're aiming for? I'll just say, well, can we get faster than my laptop? Is that something that we could achieve? And I try to say it with a straight face, even though I'm clearly about to pull someone's pants down when we have this discussion. This leads to a lot of frustration and angry finger pointing, but I just want to find out, how fast can the SAN go? And sometimes the SAN administrator will say things like, well, you're not really pushing the thing hard. It could go way faster than that. I'm looking at the dashboard and you're hardly moving into the red area. You're just, the needles in the SAN software say you're down in the green. Okay, make it go faster. Well, it's a function of how you do the, okay, show me. Set up any kind of test you want, any VM you want. It doesn't have to be on my SQL Server or any SQL Server, any hardware that you want. You go build a machine and you push the needle up into the red. Show me what the SAN is capable of. Well, according to the brochure, no. You show me what our SAN is capable of. Because see, the speedometer on my car, I have an Infiniti G35X. It's old. It's like 2008 these days. The speedometer these days, it's always been a 2008. It's not like it changed. The speedometer on the dashboard goes up to 140 miles an hour. My car won't go 140 miles an hour if you push it out of an airplane. It's not going to happen. That's just numbers on a dial. I won't tell you how fast it goes because it goes fast, but not 140. So it's also not fast to 60 either because it's all-wheel drive. It takes a little while to get started. But the idea here is that those numbers on the dashboard don't mean anything until you can actually push the needle to a number. That's what I'm going to challenge the SAN guys to. You just show me how fast it'll go. I don't care what the number is. Just give me a max that we're going to be able to achieve. And if you want to know what's good for storage, like what Microsoft recommends or what it might require for SQL Server, is we want to find out that that the storage can deliver SQL Server's maximum consumption rate. How quickly SQL Server can devour data. If it's not in RAM, what would it take to get SQL Server to go to 100% CPU? If you hooked up SQL Server to an unlimited throughput storage device, if you just let SQL Server can consume an unlimited amount of storage throughput, what would it take to push SQL Server to 100% CPU? Because most of us, when we think our SQL Server is busy, we remote desktop in and it's doing like 5% CPU, 20% CPU. What would it take to really make that go to 100%? Well, we'll take a bio break, and when we come back, I'll show you what it takes for SQL Server to get to 100% CPU and how fast your storage subsystem would need to be if you couldn't cache data in memory.